Hello again, Mr. Dean, Mr. Ward, pre-calc students. Today is day 2 of Unit 2. Our focus for the day is on solving systems of equations, which is 2 or more equations that are solved simultaneously, as well as solving cubic equations. So let's start with doing systems, and we'll do them algebraically. First one we have here is a linear. So I'd envision in my mind's eye, if I have 2 lines, I have 3 choices. I have them intersecting at one point, I have them parallel and therefore having no solutions, or I have them the same line and having infinite solutions, every point on the line. How I'm going to solve this one, you should have 2 tools in your toolbox you should be very familiar with. That is elimination and substitution. And this being pre-calc, you should be good at both of them. Use the correct one at the right time. For example, I see this right here, y equals. In my other equation, I'm going to substitute, or wherever I see that y, I'm going to replace it with what it equals. So 4y minus 4x equals 8 becomes 4, 3x minus 2 minus 4x equals 8. I created a single variable equation, hence I can solve it. Now I just got some easy algebra. 12x minus 8 minus 4x equals 8. Take the 8 over. 12x minus 4x is 8x. 16x equals 2. But I'm not done. What have I found? I found the x coordinate of the solution. I'm now looking for the y. I can plug into either one. I would prefer this one. A little bit easier for me. Y equals 6 minus 2, which is 4. So the ordered pair where those 2 lines would intersect is 2, 4. And don't forget, algebraically, 2, 4 is the only ordered pair that will work in both equations at the same time. Lots of points will work in either one. The only one that will work in both is 2, 4. And you can test it out if you want to on equation 2. 4 times 4 is 16. 4 times 2 is 8. 16 minus 8 is 8. All right, another linear. Maybe not set up for substitution. Let's do our other method, which is elimination. I'll put a little S for here for sub. All right, sub. Elimination, what's that mean? Well, if I'm going to eliminate, I want to get one variable to drop out. And I've got to get the coefficients of that variable to be the same number but opposite signs. So I can do a lot of things. I can get the x's to drop out. I can get the y's to drop out. I'm going to do the easier way. Get the x's to drop out by multiplying that equation by negative 3. Negative 3x minus 6y equals negative 3. Bring down the other one. Positive 3x minus 5y equals negative 8. Combine these 2 equations, totally legal. 3x minus 3x is gone. Negative 11y equals negative 11. Y equals 1. And again, don't forget, I'm just finding the y order of the ordered pair. I've got to still plug in y plus 2 equals 1. I'm sorry, x plus 2 equals 1. X equals negative 1. Again, the ordered pair, negative 1, 1 is the only point that would work into both, or if I graph them, they would intersect at that point, negative 1, 1. All right, now I've got a nonlinear pair, nonlinear system. Let's be visual. You guys are really good with your graph theory. That's an x squared plus 1, a normal parabola with a vertical shift of up 1. If I want to be visual, I would have to get the second one y ready. I can do that quickly. Y-intercept of 1 and a slope of 2, up 2 over 1. I would see something along those lines. Hence, I'd be finding 2 points of intersection. So let's do it instead of graphically. Let's do it analytically. Again, I see substitution here. That y equals is ready to go in my other equation. 2y minus 4x minus 2 equals 0. What do I replace that y with? X squared plus 1. Now I got some good algebra that we all like. GCF. What have I found? I found x equals 0, x equals 2. Is that an ordered pair? Heck no. Those are the 2 x's Could that be 0? Sure could. Could that be 2? Sure could. And I'm going to plug them into the easier of the two. I find this one to be easier this time. Y equals 0 squared plus 1. Y equals 1. So one of my order pairs is 0, 1. Yes, it is. And y equals 2 squared plus 1. Y equals 5. The other order pair, and again, must be written this way, 2 comma 5. Yes, it is. I guarantee you those 2 points would plug into any of these equations and work perfectly. Just as easily could have graphed and found their intersection. So you need to be, and again, this is pre-calculus, solid with elimination, solid with substitution, on linear systems or on non-linear systems. That's what the homework problems are for. If you need some practice, by all means do it. All right, let's use our calculator a little bit. If we want to solve these systems of equations graphically, of course we got to get them Y ready. We can plug these in real quick, but the point is to use a calculator. Let's see if I can find mine. There it is. Both of them are Y ready. That's a term I use in my algebra classes. Ready to be graphed. 9 minus 2x and x minus 3. Hit the graph. Line zoom 6 to get it back to center. Yep. Get the sketch. If I'm solving it graphically, gotta give me something. That looks like that one. That looks like that one. First quadrant solution. Second calc 5, just like I got at the top of your notes. Second calc 5. And since we only have 2 functions, first curve is the blue one, y1, enter. Second curve is the red one, y2. You could guess if you want. It looks to me like about 1, 2, 3, 4, 1. Let's see if it is. Most certainly. What happens if you have a nonlinear or if you have an intersection that's not nice and integral? Well, the calculator does a great job on that. Let's get both of these y ready. Y equals negative 2x plus 6. In my mind's eye, a y-intercept of 6 and a slope of negative 2. This one, y equals x squared. Normal happy parabola. Again, I use the calculator. We could do this analytically. By all means, we just practiced it. Substitution, elimination. Let's put in the negative 2x plus 6. Let's put in x squared. Graph. Just what I expected to happen. Now, that second intersection point top left is off the screen. I don't know if the calculator will find it or not. I'm not even going to bother. I'm going to up my window. What I need is more y. So I'm going to go to my window, see what the y max is. 10, not enough. I'll go to 20. Let's see if that's enough. I'm sorry. That's the y. I got to change, not the x. X stays 10. Y max is 20. Much better. Second calc, 5. You got to slide your spider closer to one or the other. I'm sliding it left, you get closer to the other. To the left one, I'm sorry. Blue, red, guess. Anything that we give you that's irrational this year, unless we tell you otherwise, we would like you to carry it to 3 decimal places. Normal happy parabola. Nice negative sloping line. Intersection of the second and the first quadrants. That point right there, let's call it P1, which is negative 3.646, comma, 13.292. Let's find P2. Second calc, 5. Slide over to the other one. Oops. I can't hold it, I gotta tap it. Close enough. Second point of intersection is 1.646, comma, 2.788. 0.708, sorry. All right. Solving systems of equations analytically as well as graphically. Got that down, use a calculator, irrational numbers. I think we're good. Moving on. Cubic equations. What does that mean? We got some x cubes in there, which there's a theorem, you probably are all aware of it, but what it says is the degree of the polynomial, the largest exponent, dictates how many solutions there are. So when it's a cubic function, I'm expecting 3 different answers. So in this first case, we're going to factor GCF. Old school, tee it up. 3 and 2, adds to 5, multiplies to give you 6. I'm not going to insult your intelligence by having to do this all the time. I'll do it once. X equals 0, x equals -3, x equals -2. Beautiful. All right, next one. Pull out more of a GCF, 3x. I don't want to do that. We've only got a few minutes left. If we have time, we'll come back to it. I want to do this factor by grouping instead. I'm going to do this one as a 2, 2 grouping. And I want you to remember, it's this. X cubed plus 3x squared plus -4x minus 12. I squeeze that parentheses in, but it's a plus in there. That's not FOIL. That's a way different equation. And I'm going to pull a GCF out of this pair, leaving with x plus 3. My goal is to have that x plus 3 to be a GCF on the other side. What can I pull out? A -4. What's left? Just what I was hoping, x plus 3. Now that x plus 3 is what I'm pulling out. Just like I pulled this x squared out and I was left with x plus 3, I'm pulling this x plus 3 out, and I'm left with x squared minus 4. Which, very easy to factor. There is no y in any of these, so there's no ordered pairs. We're just finding solutions. -3, -2, and 2. Let's do one more. Call it a day. Let's factor by grouping. Again, you can put parentheses in. I'm going to go a little bit longer. 2x cubed minus 8x squared plus -6x plus 24. GCF at first pair. Just pull out as much as you can. 2x squared, x minus 4. That, I hope, is the binomial I get. I could pull out a 6, but I want to pull out a -6, leaving me with that, x minus 4. Beautiful. Binomial is now common. What's left? Factor that, I can pull a 2 out. What are my solutions? Well, remember when you're teeing it up, take shortcuts, but know what you're doing. 2 can't equal 0, so that doesn't give me a solution. X minus 4 equals 0, so that gives me x equals 4. X squared minus 3 equals 0. X squared equals 3. X equals positive or negative radical 3. So those are our 3 solutions. Radical 3, negative radical 3, 0.4. If we solve that on our calculator, we'd find radical 3 to be about 1.7, something like that. We have a tiny bit of time left. If you want to go back up to this one, we can pull out the 3x, leaving us with x squared plus 2x minus 15, 3x, x plus 5, x minus 3. Tee it up, x equals 0. All right. Well done, folks. That's our day 2. Tomorrow we're going to do some inequalities, quadratic and irrational, quadratic and absolute value. Things that you have done in A2, but we're going to take a little different spin on them. I want you to really grasp it conceptually. Excellent job. Have a great day, everybody. And we'll see you tomorrow.